Now let's try to do a surface from the data that we downloaded, which is the Shibor, that's the Shanghai Interbank Offer Rates for 2018. What I showed in my presentation, the figure that you can see here, this is actually from an older data set from 2014. And let's try to see how we can create such a figure using our MATLAB. So now if I go back here, let me remind you a few things first. Notice that last time we already know how to import this data set into MATLAB, and you can save this as a MATLAB workspace using this save function. Okay, I assume you already saved your workspace, the data that we downloaded after you imported it into MATLAB. You should already use this save function to save it. Or you can also use the MATLAB save workspace function to do the same thing here. After you import your data, just click on save workspace, and you can give this Shibor underscore 2018 as the name to save for this data. So now let's, assuming we have done these steps now, we can use the load function to load our data. So you can see that now my workspace contains this Shibor rates, okay? And I also actually assign the dates as a separate column. So here there is one critical thing that I would like to mention. Now this data set is in the table format, as you can see. But for more convenient for the rest of our code, it is better to convert this into a double precision, because we are working with the interest rates. So it is better to work and convert them into double precision columns. And how can we do that? So we can use the table to array function. So one question might be, can we just apply this table to array function to the whole table? Is it going to work? The answer is no. Why it didn't work? Because the first column consists of the dates, and the rest of the columns consist of the interest rates, which are suitable for double precision numbers. So what we need to do is basically split the first column from the rest of the data. So we can do that. So I assign the first column to this dates vector here. And for the rest of my columns, I'm using 2 to the end. So these are the rest of the columns except the first column. And I am redefining my Shibor with this operation. You can see that. Now our Shibor basically table shrinks in size because we eliminated the first column. And then you can apply now the table to array function directly to the whole matrix now, which is actually all of them are suitable for double precision numbers now. And let's continue and let's check. Now the rates you can see are basically converted to double precision, and it's a matrix now. We can do all sorts of mathematical operations now, such as interpolation, of course. And now I need to define my x-axis to start with, because my data observations are coming for different time to maturities. As we know from our data, the first column corresponds to the overnight interest rates. And in 1 year, usually we approximate that there are 250 trading days. So the 1 day can be represented as 1 over 250 in terms of annual notation. And we have also the 1 week as the next time to maturity. And we have usually 52 weeks in 1 year. So we can write the 1 week maturity as 1 over 52. And 2 weeks maturity, we have 2 over 52. And then we have the 1 month Shibor rate, which we can denote the time to maturity as 1 over 12. And you can represent the others similarly. And the maximum time to maturity in the Shibor market is the 1 year. So we just have the 1 year as the last maturity term. So let's continue. Click. And we can see that we construct a grid. So the grid here is going to be used for interpolation. And we want to interpolate at a finer sample of points, it's a finer sample of maturities compared to what we have started here. So the grid is going to be from 1 day all the way to 1 year, and this is going by the increments of 1 day. So for each day, we will actually interpolate the value of our Shibor rates using the linear interpolation that we discussed. And I also need to construct a new matrix because I'm going to need it after interpolation, and that's called as the daily yield curve here. So I define this matrix and pay attention to the size of this matrix. So this is the number of rows. The number of rows will be 173 because in our data set we have downloaded the Shibor rates for 173 trading days. Okay, so that's the number of trading days. And the other term is going to be the size, the length of this grid that we defined for interpolation. And this is going to be 250 at most, as we have already defined in our grid above. So now it's time to do the interpolation for each trading day. By doing the interpolation on each trading day, we will get a surface. So if we again go by the breakpoints, you can see what is happening here. So here what we get is the yields from our data, because our data is this rates, as I redefined, converted into double matrix here. And I'm selecting the ith row. So actually this is the ith row from the Shibor rates data. I'm selecting the ith row, which contains basically 8 different time to maturities and the Shibor rates. So these are my interest rates, and I would like to do the interpolation using the same grid, and that will give me basically row by row interpolated values of the yield curve. Okay, so now let's remove these breakpoints and run the code in one time. So now we can see that we constructed the daily curve, interpolated values of the Shibor rates. And finally, if we plot it as a surface, we can see how it looks like. So you can see that this is our surface that we created for the 2018 Shibor rates dataset. And let's look at our axis. So on one axis we have the time to maturity from 1 day all the way to 250 days, because that's the maximum here. And we can see the trading days. So this is the first day that we have in our data, which is the beginning of the 2018. And then we have all the way to something close to 180 trading days. So we can also do some minor decorations on our figure actually by using the edit here, but I think that's enough for our visual demonstration for the Shibor rates.